Hi, my name is Anton and this is Springtime in Kotlin. In the previous episodes, we have created a simple application that stores the messages in the database. This time, let's see how can we test it. There is a starter called Spring Boot Starter Test, which brings in all the dependencies including JUnit and assert.j. We also need to make sure that the Gradle lifecycle is configured to use JUnit platform for running the tests. So we are good to go. Let's see how a simple JUnit test looks like in Kotlin. Essentially, the tests in Kotlin will look almost the same as if they are written in Java. However, we can give the tests nice names that look like real human readable sentences. Let's use the assert.j syntax to implement the simple test. It will be a very naive implementation. I will check that 1 plus 2 is equal to 3. I'm going to use the assert.that method. 1 plus 2. I'm gonna import it and going to check if it's equal to the expected result, and then we can just run it. Cool, it runs and it passes. Okay, let's get back to our Spring application. There is already one test that uses the Spring Boot test annotation. It would actually be a good idea to add some configuration. Since the tests will actually start a full Spring application, it makes sense to tie it to a random port. We could use a slightly different configuration for our H2. For instance, we could use the in-memory configuration for the tests. So when the test runs, we will have a full application running and we can make the request to the endpoints and verify the results. To execute the request, we can use Spring's test REST template, which could be injected into the test class by using the auto-wired annotation. Let's create a simple test now. There is one endpoint that simply responds with a message. So we are going to make a request to that endpoint. We are just going to verify if the endpoint responds with some text that we expect. So I'm going to use the test REST template to execute the request. And I just need to assert that the status code is equal to OK. And I will also assert that the response body contains the text that we wanted to receive. Okay, that's simple. We can simply run the test now and see if it passes. For now, I will be optimistic and will not make sure that the test actually fails. Now let's create a test that will post some data to the application and we will verify if we can retrieve the same data back. I'm going to create a new test and call it testing if we can post and retrieve the data. First we need to generate some random ID, and then I just need to create a message instance. And all we need to do now is to post this message to the application. Now let's make a request to the application and verify if we can get back whatever we just posted. And we can just verify that the status code is okay, that we can find the message ID in the response body, and if the message text is also there. However, what I don't like about this test is that we just match against the whole response and we don't verify the specific message. So let's try to do something different. Let's use the getForObject function instead. This function actually returns a nullable type, but I'm absolutely sure this time that it will not return null, since the test will fail in that case, and that is totally okay. So I can use the double exclamation mark here. to declare that the message object will not be null. And I will assert all the same attributes, but using the message object. This time, the test should actually fail. And the test fails because the JSON response could not be parsed. This is because we expect one message object, but the application actually responds with a list of messages. And it actually doesn't make sense. So let's fix the application instead. See, this method should return a message instead of list of messages. And we also need to modify this findMessageById function to return a single message. So instead of returning the query result directly, we need to call the first or a null function on the result. Consequently, in the controller, I want to respond with the status code not found if we did not find the message. So I'm using the ternary operator to throw the response status exception, and that is totally a idiomatic way to use ternary operator. If we check for some value, and if it's null, then we throw an exception. Now the test passes. Let's now add a test where we try to retrieve a message that doesn't exist. So we can test the application response with the status code not found. So we need just to generate the random ID again, make the request to the application, and check if the response is not found. Let's run the test. Nice, exactly as expected. Okay, that was quite intuitive and straightforward integration testing approach. A test bootstraps the application, we can make requests to the application and verify the responses. Regarding integration testing, this time our sample application is very simple, and it uses H2 database for convenience. In real life, you probably will be using a more sophisticated database like MySQL or Postgres. In such case, I would advise to use test containers to run a real database inside a Docker container instead of replacing your database with H2. To test just the web layer without using the database, Spring provides the MockMvc class. Let's see how to use it. So the new test is marked with WebMVC test annotation and MockMvc instance is auto-add. This time I have to add a couple of dependencies to my project. MockK is like Mockito but is better suited for Kotlin, and Spring MockK helps to use MockK library with Spring. Let's create a test that will verify if the application responds with the list of messages that we specify. The message resource class of our web application requires a message service bean, and therefore we need a mock instance of the message service in our tests. By using MockK methods, we can now declare that whenever the application invokes findMessages function of the service, it should return a predefined list of messages back. Now we can use the MockMvc instance to make a request and validate the response. For MockMvc, Spring adds a number of Kotlin extension methods for convenience so that the code that we write in tests would look really nice. Since the response is a JSON document, we can match the corresponding elements with the expected values. And at the end we can verify if the findMessages function was actually invoked just a single time. Let's run the test again. And it passes. Alright, in this episode you have learned how to write tests for Spring applications. We created a few integration tests with the application running against the database, and also we have created tests for just the web layer with MockMvc and MockK library. And there is a number of Kotlin extension functions that Spring provides for writing the tests. Don't forget to subscribe to our channel, and thank you for watching. Have a great day.